Let's practice making connections between quantum numbers and the periodic table. When we have a given set of quantum numbers, we can use the periodic table as a guide to determine which element we're focusing on. And we can also find a given element on the periodic table and determine quantum numbers based on its position on the periodic table. So let's practice how we can do this. The first quantum number is n, or the principal quantum number, and this tells us the energy level or shell. We can determine this using the different rows in the periodic table, or periods. So our first period is n equals 1, our second period is n equals 2, and this continues down the entire periodic table. L, or the azimuthal quantum number, helps us determine the subshell. And this, we may recall, is S, P, D, or F. And so our S subshell is our first two columns here. The right side of the periodic table is our P subshell. Composed mostly of the transition metals is our D subshell, and the series at the bottom are our F. The M sub L is the magnetic quantum number, and this helps us determine our orbital. And so for S, we only have M sub L equals 0. For P, we have the px, py, and pz orbitals for different orientations. So we can have M sub L equals -1, 0, and +1. And for D, M sub L can equal -2, -1, 0, +1, and +2. And we will do an example after to help us determine how we can do this. Our final quantum number is for spin. And you can denote this as an up arrow or down arrow. But the more typical way is +1/2 versus -1/2. So let's do an example. What are the quantum numbers for chlorine? So let's write this at the bottom. For chlorine, what is our N? We can highlight on the periodic table that it is in period 3. And so our N is 3. Our subshell is P. And so we didn't reiterate what the quantum numbers are. So S equals 0 for L. For P, we have 1. And D, our L equals 2. F, our L equals 3. So our quantum number for chlorine for L is 1. When we're looking at our M sub L and trying to determine the orbital, we can go across the p orbital with -1, 0, +1, -1, 0, +1. And so our M sub L quantum number for chlorine is 0. And now, going back to our M sub S, we know that we must fill each orbital first before pairing up the electrons. And so when we go across, we have spin up, spin up, spin up, spin down, spin down, spin down. So we know our M sub S is spin down, or -1/2. And there you go. Those are our practice problems for chlorine.